When something goes missing without a trace, it's usually pretty difficult to find. Now, put that thing on Mars, and well, it becomes virtually impossible.
Yes, it's been a mystery for more than 10 years. What on earth happened to Beagle 2?
What if Mars isn't as empty as we thought? Mars rovers have captured some incredible images over the years. But among the barren landscapes and red rocks, there are sightings that have left scientists and space enthusiasts alike scratching their heads. Could these strange shapes and objects be spacecraft? Or something even more mysterious? A lost explorer. Mars is no stranger to intense weather. Dust storms, especially during the summer in its southern hemisphere, can quickly escalate into massive whirlwinds. Take January 2022, for example. One such storm grew so large it covered an area nearly double the size of the United States. With an environment as tough as Mars, it's easy to wonder, could a storm like this be behind the disappearance of some of the robots we sent there? The planet is practically an alien desert, with powerful winds and average temperatures sitting around -81 degrees Fahrenheit. And during winters at the poles, the cold plunges further to a staggering -220 degrees. Explorers like landers have to be built tough to survive conditions like these. Researchers believe the Beagle 2 lander was prepared for the challenge, but the mission didn't go as planned. Just south of Mars' equator, where rugged craters meet smooth plains, lies a massive expanse bigger than Texas. This spot, called Acidus Planitia, is believed to have been shaped by a jaw-dropping impact over 3.9 billion years ago. Today, it's a dusty graveyard for one of Mars's most unfortunate robotic guests. Let's rewind to 20 Christmases ago. Britain's Beagle 2 spacecraft landed on Mars with high hopes, but things went south almost immediately. The poor thing barely made it to the surface before going silent for good. Now it's a faint, dust-covered glint on Mars's rusty terrain, visible only through the sharpest lenses. It's a dark reminder that landing on Mars isn't just tricky. It's a full-on showdown with a planet that doesn't make anything easy. So Beagle 2's disappearance was one of those mysteries that just wouldn't quit. Early on Christmas Day in 2003, it started its descent to Mars's surface in seemingly good shape, only to vanish like it was wiped off the radar. Its landing zone, near the eastern edge of the massive 930-mile-wide Acidus Planitia, became a focus for orbiting spacecraft. They combed the area for any trace, but Beagle 2 was so tiny, barely 6.5 feet across when fully opened, that spotting it was like trying to find a needle in a Martian haystack. For years, most people thought the 73-pound lander was gone for good, lost to the dusty abyss. It was chalked up as yet another name on the long list of failed missions to Mars. A planet that once may have held sprawling lakes, life-friendly minerals, and maybe even the faintest hints of early life. But Beagle 2 wasn't just any spacecraft. It carried a legacy in its name. Inspired by HMS Beagle, the ship that took Charles Darwin on his groundbreaking voyage in the 1830s, this robotic explorer had its own mission to uncover secrets of life on Mars. The plan: spend 6 months digging into the Martian soil, searching for chemical clues of ancient life. Its 43-inch robot arm was loaded with high-tech gadgets: stereoscopic cameras, a microscope, spectrometers, a sampling drill, and even a burrowing mole. Basically, it was a mini science lab ready to get its hands dirty. To reach Mars, Beagle 2 caught a ride on Mars Express, a 1-ton spacecraft packed with 8 advanced instruments. This machine could map the planet in ultrafine detail, analyze minerals, and study the carbon dioxide-heavy atmosphere. Its 2 60-foot radar antennas even had the power to peer over a mile below Mars' surface. All of this tech had one big focus: water. Where did it go? Did it help create a habitable Mars? And most intriguingly, could it have supported life? These were the mysteries Mars Express and Beagle 2 were designed to crack open. Speaking of Mars Express, it was a groundbreaking moment for Europe. It marked the European Space Agency's first solo mission to Mars. After the disappointment of the Russian-European Mars 96 mission, which failed during launch in 1996, ESA decided to take matters into its own hands. The perfect opportunity arose in May and June 2003, when Earth and Mars were at their closest, just 34.8 million miles apart. But there was a catch. The team had to develop, build, test, and launch the spacecraft within a ridiculously tight timeline. To save time and money, engineers repurposed existing hardware, gave full control to contractor Matra Marconi Space, and introduced new management strategies. Mars Express cost just 150 million euros, about 175 million US dollars back in 1999, or 316 million in today's money. The name Express wasn't just clever branding, it reflected both the rapid development cycle and the fact that the trip to Mars would take only 6 months. There were hurdles, of course. A faulty electronics module caused delays, but Mars Express finally launched on June 2, 2003, atop a Soyuz-Fregat rocket from Russia's Baikonur Cosmodrome. After a 6-month cruise through space, Beagle 2 separated from the spacecraft on December 19. Over the next 5 days, it hurtled toward Mars. With a heat shield, parachutes, and airbags to protect it, the lander was set for a gentle touchdown on Christmas morning, though fate had other plans. The fate of Beagle 2. Europe's Mars mission didn't quite go as planned. Beagle 2, the little lander that was supposed to dig into the Martian soil, just stopped talking. NASA's Mars Odyssey orbiter tried reaching out. The UK's Jodrell Bank Observatory gave it a shot. Even Mars Express flew over its landing zone to send a signal. But nothing. Silence. Beagle 2 had vanished, leaving everyone scratching their heads. By February 2004, they had to call it. Beagle 2 was officially lost. A later investigation didn't point to one big mistake, but instead flagged a mix of design and management issues that made things tricky from the start. It wasn't the ending anyone wanted, especially for a mission that had so much riding on it. Still, it left behind a valuable lesson. Mars isn't just hard, it's relentless. The hunt for Beagle 2 didn't end with its disappearance. In fact, it became a lingering puzzle. In 2005, NASA's Mars Global Surveyor spotted a mysterious black smudge on the Martian surface, sparking excitement that it might finally be the missing lander. But hopes were short-lived. After a closer look, it turned out to be just an eroded crater. Fast forward to January 2015, and the mystery finally got a break. NASA's Mars Reconnaissance Orbiter, using its powerful high-rise camera, spotted something that stood out from the typical Martian terrain. Detailed images revealed multiple objects in exactly the spots where Beagle 2's heat shield and parachute were expected to be. The shapes, structures, and even their shadows matched what you'd expect from the lander. After over a decade, Beagle 2's final resting place was no longer a secret. Finding Beagle 2 was a huge breakthrough. It turned out the lander had actually touched down safely, landing incredibly close to its target. But there was a heartbreaking twist. Only 2 or 3 of its 4 petal-like solar panels had deployed, leaving its radio antenna blocked. Beagle 2 was there, fully intact, but unable to call home or share any of its discoveries. It was a bittersweet moment. The joy of confirming a successful landing was overshadowed by the what-ifs. To make it harder, Colin Pillinger, the driving force behind Beagle 2, had passed away just months earlier in May 2014. He never got to see the proof that his brainchild had made it through the perilous journey to Mars. But Pillinger did live to witness the incredible accomplishments of Mars Express, which continues to make history. As the second longest operating Mars orbiter, trailing only NASA's Mars Odyssey, it has been circling the red planet for nearly 20 years. From its unique orbit, Mars Express has confirmed methane in the Martian atmosphere, mapped auroras spanning the planet, and even discovered clouds floating 50 to 60 miles above the surface. Mars Express has been a treasure trove of discoveries, uncovering evidence that water once shaped the red planet's surface. From signs of ancient flooding at Mangala Vallis to a frozen sea in the equatorial Elysium Planitia, and from ice patches in Vestitas Borealis to sulfate deposits in Juvente Chasma, the orbiter painted a picture of a Mars that was once far more hospitable. It even found possible river channels at Nepenthes Mensae and Rover, hydrated silicates in the northern highlands. And in 2019, it revealed a hidden underground network of lakes, 5 of which contained minerals crucial for life. The mission didn't stop at water. Mars Express helped explain how the solar wind likely stripped away Mars's atmosphere, and in 2007, it observed raging dust storms that spiked global temperatures by 68 to 86 degrees Fahrenheit. It documented fascinating wind-shaped features like yardangs, as well as escarpments and landslides. The orbiter also helped scientists piece together the timeline of Martian volcanic and tectonic activity, stretching from 3.8 billion to 100 million years ago. Mars Express even turned its attention to Mars's moon Phobos, discovering it's not much more than a loose pile of rubble with a porosity of 25 to 35%. And as if to make up for Beagle 2's misfortune, the spacecraft played a key role in guiding NASA's Phoenix lander in 2008 and the Curiosity rover in 2012, helping them stick their landings with pinpoint precision. In a delightful twist, its visual monitoring camera, initially designed just to keep an eye on Beagle 2, was repurposed in 2008 as a Mars webcam, bringing the planet closer to the public. Now, with over 20,000 orbits under its belt and operations extended until at least 2026, Mars Express isn't done yet. There's plenty more of the red planet waiting to be revealed. Still, Beagle 2's struggle to deliver answers about life on Mars has left scientists pondering a big question. Can we really count on robots to uncover the secrets of extraterrestrial life? Sure, they're packed with high-tech tools and can go where humans can't yet, but when missions fall short, like Beagle 2, it raises doubts about whether robots alone can crack one of humanity's greatest mysteries. Is it time to rethink how we explore? Or do we just need better tech and a bit more luck? Are robots alone enough for Mars? When a Senate subcommittee asked for compelling reasons to send humans to Mars, Ellen Stoffen, NASA's former chief scientist, delivered a mic drop moment. Stoffen laid it out clearly. If we're serious about uncovering ancient life on Mars, humans have to step in where robots can't. She explained that while she's hopeful life once existed on Mars, it likely didn't get much beyond fossilized microbes. Tiny, incredibly hard to detect traces of life. Finding those fossils is no small task, Stoffen told the subcommittee during a science-focused hearing. She emphasized that even the best robots might miss what a trained human geologist could spot in person. So if we want real answers about Mars's ancient life, it might be time to start planting some boots on the red planet. NASA hasn't sent a robot specifically designed to search for life on Mars since the Viking missions way back in the 1970s. And with the first possible human mission still at least 15 years away, it's fair to ask, can robots crack the code of ancient Martian life before humans set foot on the red planet? The challenge is massive. As Francis Westall, an astrobiologist from France's National Center for Scientific Research, pointed out, even finding traces of ancient microbial life here on Earth is incredibly tough. It's still pretty controversial, she said, even with access to the best labs and tools on the planet. Her work always requires a team effort. Humans in the field and high-tech labs. Robots? Not part of the equation. Mars adds another layer of difficulty. Sean McMahon, an astrobiologist from the University of Edinburgh, explained that most living things never fossilize, and those that do usually have hard parts that are easier to preserve. If Martian microbes didn't leave behind anything solid, the odds of finding traces billions of years later get even slimmer. Whether it's a human team or a robotic one, the search for ancient life on Mars might be one of the hardest puzzles we've ever tried to solve. When it comes to finding ancient life on Mars, the red planet might actually have an edge over Earth. Unlike here, where plate tectonics and volcanism constantly erase the geological record, Mars has preserved its history for billions of years. Tanja Bosak, a geobiologist from the Massachusetts Institute of Technology, explains that if life ever existed on Mars, there's a decent chance its traces are still out there, waiting to be found. Mars has already hosted 8 successful landers and rovers, with NASA's Curiosity rover currently stealing the spotlight. Its mission? To search for environments where life might have thrived, not to directly hunt for life itself. And it's been successful in that role, identifying mudstones in Gale Crater as prime real estate for ancient microbes, and even detecting organic molecules that hint at the potential for life. But let's be honest, robots can only do so much. Curiosity has done incredible work, but Martian geology is still a massive puzzle. Even after rovers have studied and analyzed rocks, scientists are often left debating what those rocks actually tell us. Sean McMahon sums it up perfectly. There are rocks rovers have visited, imaged, and analyzed, and we're still arguing about what they are. It's proof that while robots are valuable, they're not the whole answer. And the debate about whether humans or machines are better equipped for the job rages on. Robots have one big advantage over humans. They're tough. Ken Farley, an astrobiologist at the California Institute of Technology and lead investigator for NASA's next Mars rover, pointed out that robots have proven they can land in challenging terrain, getting closer to the rocks scientists want to study. Humans, on the other hand, are far more limited. As mobile as astronauts are, Neil Armstrong and Buzz Aldrin only walked about 90 yards during their historic moon landing. When it comes to searching for ancient Martian life, robots are perfectly suited for the job in many ways. Since scientists are looking for tiny microbial traces, these features easily fit within a robot's field of view. But while robots can zoom in on the details, they lack the bigger picture perspective that humans bring. Former NASA chief scientist Ellen Stofan told senators that geologists, biologists, and chemists on Mars wouldn't just find evidence of life. They'd analyze its complexity, variation, and connections to life on Earth in ways robots simply can't. Frances Westall agrees. As a field geologist, she knows the power of first-hand observation. "When I go into the field, I need to see things with my own eyes," she said. Robots, no matter how advanced, lack the instincts and adaptability of a human scientist. Westall even joked that if given the chance, she'd jump at the opportunity to go to Mars herself. After all, she said, a human geologist can do in a week what Mars rovers take a year to accomplish. What if we didn't have to choose between robots and humans to unlock Mars' secrets? The solution might be in the middle: sample return missions. These allow robots to collect rocks and soil on Mars and bring them back to Earth, where scientists can study them in the full glory of advanced terrestrial labs. NASA and Japan's space agency are already proving this concept with asteroid missions, and Mars is next on the list. Ken Farley highlighted the unique advantage of sample return missions: flexibility. Once scientists have samples in hand, they can explore questions they didn't even know to ask when designing the mission. He brought up the famous Allen Hills 84,001 Martian meteorite, once thought to hold fossilized life, a theory later debunked. The argument hinged on finding tiny magnetic minerals, but that kind of discovery required tools no one would have thought to send to Mars. Then there's the practical side of getting equipment to Mars. Instruments that make the journey must be lightweight, compact, radiation-hardened, and energy efficient. That limits what can be done on the planet itself. As Tanya Bosak explained, unless we somehow build a Mars superlab, bringing samples back to Earth is essential. It's about the lab, and not just one, but multiple labs with an entire program dedicated to clean, precise analysis, she said. With sample return missions, we get the precision of Earth's top labs combined with the reach of Mars rovers, a winning formula for solving the mysteries of the Red Planet. This brings us to NASA's next big step, the Mars 2020 rover. While it's built on the same framework as Curiosity, its mission is laser-focused on finding signs of life, not just hunting for environments where life might have existed. And it's taking things a step further by gathering and stashing Martian rock samples, carefully selecting pieces that could be retrieved by a future mission and brought back to Earth. Imagine that, a pound of Mars, right here in our labs. Sure, humans could fetch those rocks just as well as robots. After all, if we figure out how to bring astronauts back from Mars, a few extra pounds of rock won't be an issue. But here's the thing, robots have earned their stripes. Everything we know about Mars being potentially habitable or hiding traces of ancient life has come from our robotic explorers. While a human mission could bring unique benefits, arguing for it on the basis of finding life might not be the strongest case. As Tanya Bosak put it, the value of human exploration is exploration itself. Humans going to Mars is about the sheer adventure and curiosity of stepping foot on another world. Finding life, though? That's a separate mission, and the robots might just keep leading the way for now. Should robots continue to lead the charge in the search for life on Mars, or is it time to put humans on the Red Planet? Let us know in the comments. If you enjoyed the video, don't forget to hit the like and subscribe button for more.